Hello students, now in class 12th today I will tell you about the equilibrium of the system of two similar charges. Topic is equilibrium of two charges. Suppose we are given two charges Q1 and Q2 which are at distance r from each other. Let two charges each of magnitude Q placed at distance r apart. Suppose this is the a charge Q, this is the another charge Q. The distance between them is given to us. This is now your r. Then being the two similar charges, they will apply the repulsion force on each other. So this will be like this one, F. So they will repel to each other. It means that they cannot exist together. This system of charges cannot remain in equilibrium due to repulsive force. Then what? To make this system in equilibrium, naturally a third charge of the opposite nature should be kept between these two charges. To make it in equilibrium, a third charge Q of opposite nature must be placed between them. This means what? That this is the charge Q, this is now charge Q. The distance is given to now R, so this, suppose we place another charge, this Q here. This is at distance x from this A, this is now B, this is A, this is now B. Then as a result, there will be the force between all these three charges, and then this distance will be r minus x. We have to find the equilibrium of these two charges, A and B, placed at the points A and B. The force on either of these charges must be 0. So net force on this charge, either this charge at point A or the charge at point B, that must be equal to 0. for equilibrium, the net force on either charge Q should be 0. It means the net force must be equal to 0, so this F should be equal to 0. Now the force on this one, this now the let this force because of on this one the charge Q, let's this is equal to 1 upon 4 pi epsilon naught into Q upon x square plus 1 upon 4 pi epsilon naught into this is now your Q square upon R square. This should be equal to 0. We have to find the force on this one charge A or on this charge B. So if we take the charge B, then this will be now to R minus X. So now you can find this to be these two factors will cancel. This Q will also cancel from here. So this is now your Q upon X square plus Q upon R square. This is equal to 0. So what we have that this Q upon X square equal to minus Q upon R square. So what we find that this the nature of Q will be opposite to the nature of this one. So this Q will be of negative charge. The charge Q must be negative. If these two charges are positive, then this must be negative. And if suppose these two charges are negative, then this must be positive, opposite nature. I have said here that a charge Q of opposite nature must be placed between them. Then the distance from this one that we can find if take the magnitude Q upon X square equal to magnitude of this minus Q upon R square. So this Q is equal to your Q into X square upon R square. Or this X square equal to Q into R square upon X square. So this X is equal to this is now your Q. This we have to find the X. X to Q R square upon this charge Q. Q R square upon Q. So X equal to square root of Q into R square upon Q. So now you can find the magnitude of this one. If suppose we are given that these two charges are equal and this force is so much, then this R is given to you that so much, then you can find that if this Q and Q are equal, then X equal to plus minus R. Force on this one, this is now your q into q upon x square plus q square upon r square. Now this distance from this one is r. This is now r. Q square upon r square. This will be of negative, must be negative, this is the right one. And then this q, r square. So x equal to r square root of q upon q. So this will give you the distance from this point A, that this should be placed at this point. So if you are given this value of this q and this one, then you can find the value of x. If suppose that charges at point A and B are negative, then this charge must be positive. If charges at A and B are negative, then charge Q must be positive. Force on this one because of this charge q, this is now your q square upon x square, this is not so much. Then this is now okay. If you want to find out the distance from this charge at the point B, then this you take the r minus x, so that you will find this value of this, that so much distance will be there. Just putting the value of this x here, then you will find to this value. So this is the position and the nature of the charge to make a system of two similar charges in equilibrium. And if suppose these charges are not of the similar one, they are of somewhat different, then you can also find by the same thing, that if we are taking from distance from here, then this charge q, that will be now here q1, and if we take from this one, then this will be your q2. So again you can find the value of x. So by having the different values of this q, this q and q, you can find to this one. If these charges at the point A and B are equal and opposite, then no need to place a third charge for equilibrium, because they will attract to each other and they will not fly off. So they are always in equilibrium. For example, your sodium chloride. The sodium chloride, sodium and chloride, as they are having the equal and opposite charges. So this is a stable equilibrium. Similarly, HCl, sodium hydrogen chloride. Then hydrogen is positive and chloride is negative. So they are making the stable system. So when the charges are equal and opposite, then they make always a stable system. But when the charges are of similar nature, then system is not stable because of the repulsion force. So definitely a third charge must be placed between them, and this charge must be of the opposite nature of the given charges. And for the finding the distance, you can have this formula from here. So this is what the equilibrium of two charges. Thank you.